we need to minimize the undesired product. Okay, kita nak get rid lah of U ni kalau boleh through the selection of reactor types and conditions. Okay, so how do you maximize the product of D is by manipulating the reactor conditions. Okay, mainly for the temperature and also the pressure. Okay, as well as how do you select the suitable type of reactor. Okay, so the red law for this equation would be for the RT, okay, is equal to KD CA to the power of the alpha 1. Okay, this is the order of the reactions. Okay, we have the RU, okay, which is equal to KU CA to the power of alpha 2. Okay, so alpha 1 and alpha 2 actually is the order of reactions. Okay, for the desired reactions. Okay, alpha 1 is for desired and alpha 2 for the undesired one. Okay, so this is desired and this is undesired. Okay, so the sum of the rate of formation, okay, is given as below. Okay, so you just sum up both of the red law, RT plus RU, you will be able to get this one. Okay, this equation. Okay, so we go further. Okay, so alpha 1 and alpha 2 is a positive, okay? It's a positive reaction order. Okay, make sure this should be in positive. Okay, we want the rate of formation of D, which is the RD, okay, to be higher with respect to the rate of formations of RU. Okay, RD must be higher than RU. Taking the ratio of these two, we obtain the rate selectivity parameters, which is SDU. Okay, this is the term that you learned on last Tuesday. All right, all the instantaneous selectivity is given by SDU is equal to RD over RU. K is equal to KD. Okay, so K actually, okay, if you can remember from topic number 1, this one actually is caused by the effect of temperature. Okay, remember K yang dalam Arrhenius equation. Okay, so previously we only concentrate on the selectivity based on the effect of the concentrations. Okay, now for this, for today, we are looking at the temperature perspective also. Okay, so Ca to the power of alpha 1 minus alpha 2. Okay, alpha 1 ni dekat yang desired lah, alpha 2 is for undesired. Okay, then maximizing the desired product. Right, so we have two cases here, okay, whereby we will study the way to maximize the instantaneous selectivity, which is STU, for different reactions order of the desired and undesired. Okay, so there are two types. Okay, which is the first one is the if A1 more than A2. Sekejap. Sorry. Tadi ada urgent matter sekejap. Okay, so there are two cases. Case 1, if A1 is greater than A2, maksudnya yang dekat atas tu lebih besar daripada bawah. Okay, and then if A2 is greater than A1, means that RU lagi tinggi. Okay, so case 1, if A1 is greater than alpha 2, for the case reaction order of the desired product is greater than reaction order of undesired product, the difference between the reaction order A should be positive. Okay, so kalau dia greater, automatically A ni akan jadi positif. Lah sebab katakan this 2 minus 1 should be 1. So still masih positif. So the right selectivity parameter equation becomes, then you can summarize it as this one. Okay, because SDU is equal to RD over RU, KD over KU. So kalau dia positif, sebab kita dah gantikan ni, kita replace with the A. Okay, so A positif, so dia dekat atas lah, CA to the power of A. Alright. So how we accomplish this one? Okay, so remember, if it is at the top one, means that in order to have a high selectivity, alright, to favor the D, we have to increase the CA. Oops, sorry. So we have to increase the CA here. Okay, to make this ratio as large as possible, we need to keep the concentration of A as high as possible. So these are the way how to increase the concentration of A. Okay, for example, for a gas phase reaction, run it without inerts. Okay, maksudnya kita try to have a pure of A feed, alright, and at high pressure to keep CA high. Alright, for liquid phase reaction, the use of diluent should be kept to as a minimum. Okay, kalau boleh dalam liquid phase ni, especially kalau in CSTR ni, kita kalau boleh jangan ada, jangan put a diluent lah. Okay, and then a batch or PFR should be used in this case because the concentration of A start at high value and drop progressively. Okay, so yang paling sesuai adalah guna batch reactor and also yang tak ada in dengan out, alright, and also PFR. Okay, sebab dia continuous and dia akan drop progressively lah, daripada A tu dia akan menurun sebab dia akan produce D. Okay, so CSTR is not suitable in this case, concentration of A constantly at low value. Okay, sebab kita nak maintain, kita tak nak ada concentration of A ni low value lah. Okay, then we have a second case which by A alpha 2 is higher than alpha 1. So the reaction order of the undesired product is greater than the desired product. Okay, sekarang ni undesired ni lagi power lah daripada desired ni. So we define as a new term which is B is equal to alpha 2 minus alpha 1. Okay, kita nak letak A sini sebab nanti you confuse lah. So B pula adalah alpha 2 minus alpha 1 tadi. A adalah alpha 1 minus alpha 2. Okay, so we will get the SDU is equal to RT over RU. Okay, the difference is the CA is dekat bawah ni, perkan dia. Okay, so means that you need to have a low CA. Alright, low CA sebab dia dekat bawah. Okay, so kita kena decreasekan CA ni in order to increase the selectivity. Okay, so low CA favors D. Okay, so how we accomplish it? Alright, so the concentration of A should be as low as possible. Okay, so the first one is low concentration of A may be accomplished by diluting the feed with inert and running at low concentration of A. Alright, so macam mana kita nak run a low concentration of A is by using a CSTR. Okay, because the concentration of reactor are maintained at a low level. Okay, a part of that, we also can use another type which is a recycle reactor. Okay, remember yang figure yang sebelum ni ada banyak-banyak tank tu. Okay, one of it adalah kita pecahkan ada side stream. ataupun kita akan boleh buat juga recycle reactor in which the product stream act as diluent, could be used to maintain the entering concentration at low value. Okay, so now we move on to the effect of temperature on selectivity. Okay, so here actually kita kena tengoklah the main question here. Alright, should we run the reaction at high temperature ataupun low temperature, okay, in order to maximize the selectivity. Okay, so in this case, what you need to look is the sensitivity of the rate selectivity parameter to temperature can be determined from the ratio of the specific reaction rate. Okay, so kita look at this one, specific reaction rate. Okay, remember this is from topic number 1. Okay, whereby this is K is equals to A E to the power of E over RT. Okay, so we define it as a KD and also KU. Then you will have this kind of equation. Okay, and then you can simplify since there is an exponent top and bottom ni, then you can simplify like this one. Okay, so what is A? Okay, A is the frequency factor, alright, and E the activation energy. Okay, this is activation energy, and the subscript D and U referred as desired and undesired product respectively. Alright, so here we are looking at the case number 3 and 4 pula. Okay, just now case number 1 and 2 is with respect to the concentration. Now we are looking at the in terms of the activation energy. Okay, so case 3 would be ED is more than EU. Alright, and we have EU is more than ED. Okay, so if you can see the desired one here is much higher than EU, means that we need a high temperature. Okay, while for this one is EU is EU is greater than ED, means that it must be operated at low temperature. Okay, sebab dia sama je lebih kurang macam konsep concentration. Okay, right, so here let me derive again. So we have a S D over U is equals to RD over RU. Then we have a KD C A alpha 1 over with the KU C A alpha 2. Okay, so what is KD? You can put it an equation of the erroneous equation, which is AD, alright, E to the power E D over RT, okay, times with the CA alpha 1 over with the AU exponent E alpha what do you call activation energy for undesired over with the CA alpha 2. Okay, so this one can be simplified as AD over AU exponent to the power of ED over RT minus with minus EU over RT, sebab kita dah bawa ni atas. Okay, sebab dia per, so jadi minus lah. Okay, times with the CA alpha 1 minus alpha 2. Okay, so just simplify it as alpha D, alpha U, E to the power ED minus with the EU, okay, over with the RT. Okay, we have a CA alpha 1 minus alpha 2. Okay, so this one will be temperature dependent. And this one is the concentration dependent. Okay. Okay, so recall what you've learned previously. Okay, so from the erroneous equation, we can linearize it. Okay, in order to get the slope and also the intercept. So you can plot it. Okay, this is as a y, and then this would be 1 over t ni adalah x, and this is m, and this is c. Okay, so the m should be negative EA over r. Okay, so that's why you will see the slope is decreasing. Okay, the trend is decreasing in order to get a negative slope, and the intercept is ln A. Okay, so the bigger EA is, the more the rate varies with T. Okay, so lagi besar EA, sebenarnya the rate ni lagi dia akan varies lah with the temperature. Okay, so bila you tengok EA ni makin besar, okay, dia punya slope lagi jauh. Okay, sebab dia lagi besar ni, makin besar lah slope dia. Okay, so bila lagi besar, actually dia buatkan K ni akan lebih banyak varies with T. Macam ni. Okay. Macam tu lah. Okay, so activation energy, alright, which is EA, is defined as the minimum amount of energy that must be provided to compound to result in a chemical reaction. Okay, so activation energy ni, drag constant ni kena overcome dia lah in order to lower the barrier. Macam ni lah. Selalunya kita akan nak lowerkan dia lah supaya reaction tu senang occur. Okay. So if you can see, there is a two difference line here. Alright. Defined with the purple and the bluish. Okay. So if you can see, if a steeper slope means it has a larger EA. Okay. Right, so have a look for case ED is larger than EU, right, for the case number 3. In this case, the specific reaction rate of the desired reaction KD increase more rapidly with increasing temperature than thus the specific rate of the undesired reaction KU. Okay, so if you can see, this is the ln K versus with 1 over T. Okay, and you can see the KD here is located upper than KU. Alright, so means that the slope here would be higher than the KU. Okay, so this one is, we have this and this one. Okay, kalau KU dekat sini, dia akan, sorry tak tepat ni, sebenarnya kat sini. Alright, so this is for if ED over EU. Okay. The reaction system should be operated at the highest possible temperature to maximize SDU. Okay, so sebenarnya ini adalah 1 over T, bukan T. So kalau we have a very high temperature, okay, katakan 1 over 500, okay, so the value dia akan lagi kecil. Okay, kalau you dapat T dia lagi kecil, value dia kat 1 over T akan jadi besar. Okay, contohnya this one is 1 over 200. Okay, and then 1 over 500. So means that dekat higher of T, okay, you will have higher KD. Okay, faham ke? Kalau lower T, actually is for KU lah. Alright, sebab KU dekat dia makin panjang kan, memanjang kan. You tengok kat sini KU dia memanjang, so dia akan pergi sini, dia akan pergi sini. So kalau kat hujung ni sebenarnya T dia adalah T yang kecil, temperature yang rendah. Okay, sebab ni fraction. Okay, so means that KD increase, okay, more rapid than KU, alright, with increasing temperature. Okay, faham ke? Alright, good. And then, so this one lah. So SDU is equal to RD over RU, KD, CA. So increasekan ni. If ED is more than EU, run at a higher temperature so that KD increase as well as the SDU increase. Okay, so for EU, is larger than ED, means that the KU here is located upper of KD here. Alright, so here the reaction should be carried out at low temperature to maximize, but not so low that the desired reaction does not proceed to any significant extent. Okay, so there is a minimum lah of the low temperature that should be met. Alright, okay, so from here to get low T cause a low K. Alright, sebab this one towards here is a higher temperature. Okay, towards to the right side, it will have a lower temperature. Okay, so untuk KU lagi bagus. Okay, sebab dia very steep, means that temperature dia should be low lah. Okay, so in order to lower the SDU but increase the KU, run at lower T so that KU decrease, hence SDU is maximized. Okay, so kalau you decreasekan KU ni, sebenarnya kita tahu kenapa ni, this one akan increase SDU. Okay, so which is favorable lah, KU kena rendah untuk increasekan SD. Okay, alright, so we have exercise 1. Okay, punyalah malah nak type, tulis sahaja macam ni. Okay, so we have A plus B plus C will have a D product and also undesired product. Okay, so the question given you the RD and RU equation, okay, which we have a temperature dependence here as well as the concentration dependent. Alright, so how do you maximize selectivity? Based on manipulating the operating conditions, also choose two appropriate reactors for these reactions. Okay, so first you have to analyze lah the SDU in terms of the concentration and temperature, and then you kena analyze pula what is the best reactor, okay, for these reactions. Okay, so kita tengok one by one. Okay, so the solution is, alright, we need to increase, alright, increase or kita perlu maximize the selectivity. Okay, by first is manipulate concentration of reactants. Okay, the second one is kita kena manipulate temperature of reaction. Okay, hopefully you can read my cakap ayam, punya tulisan. Okay, so here, tapi kalau face to face, tulisan saya okay lah, okay sebenarnya. Cuma bila nak write down ni, dia macam agak susah sikit lah. Okay, then to increase the SDU, okay, so RD over with the RU is equals to 300. Okay, just put it this equation to the power of 10,000 over RT CA CB kuasa 2 CC over with the 200 exponent 3000 over RT CA CB CC kuasa 2. Okay, so you just simplifykan dia. Okay, in term of the CA dengan CB ni. Okay, so this one kita boleh this one is I simplify 1.5, ni jadi 1.5 lah. Okay, to the power of E negative 10,000 okay, over RT, okay, over with the E to the power of 3,000 over RT. Okay, so this one CA 1 minus 1, and then we have CB 2 minus 1, and then CC adalah 1 minus 2. Okay, so daripada sini kita boleh simplify as 1.5 E to the power of 10,000 over RT over to the E to the power of 3,000 over RT. Ya?
Yang 1 minus 1, 2 minus 1 tu kat mana macam tengok?
Ini daripada sini kita perkan dia. Sini kan 1, sini 2, ni 1. Yang ni 1, 1, 2. Ni daripada sini. Nampak ke? So daripada sini kita perkan dia kan. Kita perkan dia. So CA ni 1 kan. So 1 minus 1 lah kat bawah ni 1. So 1 minus 1. This one 1 kan. So 2 minus 1. Sebab kita nak simplifikan dia. Yang ni pula 1 kan. Ni to the power of 1 kan. So 1 ni per. So minus 2. Okey ke? Faham?
Okey, faham.
Alright. Okey. So daripada situ kita simplifikan dia. Dia akan jadi 1 over 5. So CA0 tak adalah. CA0 is equal to 1. Okay, so tinggal CB over C negative 1. So daripada sini kita boleh simplifikan 1.5 e to the power 10,000 over RT over with the e to the power of 500 over RT. Okay, so CB over CC sebab dia minus 1. So put 1. Okay, so daripada sini that's why you kena simplify, nak tahu mana satu perlu tinggikan, mana satu perlu rendahkan. Okay, so in this case we have to maximize the CB concentration but minimize the CC in order to get higher SDU. Okay. So daripada situ, okay, you boleh tulis kat sini lah, analyze satu. So untuk A pula tak ada signifikan pun sebab A tu kalau you tengok dia tak ada dah dalam equation ni. So tak ada changes. So daripada situ kita boleh cakap changing concentration of A, alright, will not affect selectivity. Okay, and then kita tengok pula concentration dekat B pula. Macam mana kita nak maximizekan B tu. Okay, so concentration of B must be kept higher. Okay, so macam mana kita nak kept higher? Kita kena feed B at higher partial pressure. Okay, and we also need to feed B without inert. Allah, tak benar tulisan. Inert. Okay, and then about number 3 pula kita kaji pula daripada segi analyze dari segi concentration of C. Okay, so concentration of C must be kept low. Okay, so how we kept low is feed C at lower pressure ataupun kita feed C with inert. Terbalikkan saja dengan B tu. Okay. Alright, so seterusnya kita kena analyse pula in term of temperature. Okay, so tengok pada E dia. Okay, so sekarang ni ED adalah 10,000. Okay, EU adalah 3,000. Okay, so daripada sini you akan tahu mana satu lebih besar, ED atau EU?
ED.
ED besar.
Alright, so automatically ni adalah case untuk ED lebih besar daripada EU. Okay, means that run the reaction at highest temperature possible. Okay, tapi as long as the temperature does not decompose ataupun degrade lah, decompose ataupun degrade the reactant. Okay, so inilah jawapan dia. Okay, alright. Okay, so untuk selepas ni you akan buat sikit penyiraan, bukan sikit, banyak sebenarnya. Okay, alright, in order to determine the optimum CA, okay, that will give a maximum selectivity. Okay, so sekarang ni kita ada new term asterisk dekat sini. Alright, in order for you to get okay, kalau selalunya you ada selectivity, okay, katakan kita ada selectivity punya what do you call it, selectivity punya value, and then selectivity ni kan akan bergantung pada RA ataupun RD pun terpulang lah. Okay, dalam term ni kita akan kaitkan dengan concentration. Okay, so daripada situ sebenarnya you boleh buat graph. Okay, graph of SD U versus with the CA. Okay, so sekarang ni yang kita nak dapatkan adalah yang paling optimum, which is the one that concentration paling tinggi. Okay, so daripada sini kalau you tengok, kalau kita ada curve means here, kita ada slope. Okay, yang ni slope akan jadi positif, yang ni jadi slope akan negatif. Okay, tapi kalau kita nak dapatkan maksimum, of course, kat titik satu ni saja dia tak akan ada slope. Means that perbezaan dekat SDY dengan CA ni tak ada beza. So bila you buat DSDU over with DCA, dia akan jadi kosong. Kita tak ada value sebab dia tak ada slope. Alright. So inilah tujuan dia, kita akan buat untuk cari optimum CA that will give maximum selectivity. So you akan differentiatekan dia. Alright. So let's say we have a SDU. K is equal to RT over RU is equal to K1CA kuasa 2 over with K2 CA. Alright. So daripada sini, macam mana nak buat? There are two ways. Alright. Okay. So first is by plotting graph SDU versus with CA, yang mana you akan dapat macam ni lah sepatutnya. Okay, ada titik optimum here, which is CA. Okay, ataupun is by differentiating SDU with respect to CA, okay, and set the derivative to 0. Okay, macam I bagi tahu tadi lah, which is ds du, alright, okay, over dca is equal to 0, alright, in order to get, okay, local minimum ataupun maximum point. Okay, in order for you to solve the CA value. Okay, so nanti saya akan ajarlah macam mana nak get that value. Okay, so let's say we have this one. Okay, so this is selectivity versus with the CA. Okay, so sekarang ni kita akan letak B over with X dengan Y. Okay, so daripada sini, okay, we have a S du is equal to RD over with the RU. Okay. So tengok balik dekat belakang ni, soalan dia adalah jap, mana soalan dia? K1CA. Jap, mana question dia? Mana tertinggal question ni? Question saya ada jot down. Okay. So let's say we have a to X. Okay, this is K1. Okay, so the R1A is equal to Rx is equal to K1. Okay, and then we have another one. Okay, this is a parallel equation. Okay, a set of equation is equal to B. Okay, R2A, okay, is equal to RB is equal to K2CA. And then we have another equation which is A, K3, Y is equal to negative, ni dua R3A is equal to RY is equal to K3CA2. Okay, so daripada sini, kalau you tengok, there are three kind of rate of fractions. Okay, we have with respect to K1, K2 and K3. Okay, let's say that the desired one is the U. Desired is the U. The desired is the B component, yang ni desired. Okay, and undesired is the X and Y. Okay, let's say dalam ni. Okay, sekarang ni we need to get what is the optimum of the rectangle. Okay, so the first thing you need to do is you have to know lah how to get the CB. ataupun dalam istilah sekarang ni, sebelum ni you akan guna CD over U kan, is equal to RD over RU. Okay, sekarang ni kita guna term baru CB, alright, SB, B is the desired one, over with the XY. XY is undesired lah, undesired adalah molekul adalah compound X dengan Y. Okay, so this one is equals to RB plus over with the U. So undesired U dekat X dengan Y. So means that this one should be Rx plus with the Ry. Okay, so remember this is the desired and this is undesired. Okay, so daripada situ masukkan balik what is RB. RB is this one which is K2CA over with the Rx. This is Rx. Okay, K1 plus with this one K3CA kuasa 2. Okay, so this is your SBXY. Okay, remember what I've said previously, you kena dapatkan, in order to get the CA benda ni, you kena differentiatekan between DSB, okay, XY over with DCA. Okay, so macam mana you differentiatekan? Okay, you kena ingat balik lah, ni sebenarnya dalam calculus. Okay, bila you ada fraction, you kena pecahkan. Okay, saya tulis balik semula lah. S, B, K, X, Y. Ni X, Y tau. Okay, is equal to K2 CA over K1 plus with the K3 CA2. Means that you nak differentiate DSB over XY. Okay, differentiatekan dia in term of ni lah, K2 CA over with the K1 plus K3 CA2. Okay, you tak boleh differentiate directly sebab you ada, masalahnya you ada kuasa 2 kat sini and then you ada per kat sini, dia ada in term of fraction. Okay, so what you can do is you kena pecahkan dia jadi D over DX. Okay, nanti I terangkan apa benda ni and then Fx GX. Okay, jangan takut, benda ni sebenarnya simple je, cuma you kena tahu konsep dia lah. Sekejap ya. GX, okay, GX, right, Fx over over GX kuasa 2. Okay. Okay. So daripada sini, okay, in order for you nak senang, okay, sebenarnya you can tahu apa function F dengan G sekarang ni. Okay, kalau you nampak, you nak standardizekan dengan ni, F ni dekat atas. Okay, so this would be the F. Okay, and G adalah per dia. So apa-apa equation kat bawah ni akan menjadikan dia G. Okay, so daripada sini kita akan kata, let's say, let sekarang ni F adalah K2CA and then we have a G which is K1 plus with the K3CA kuasa 2. Okay, so kita pecahkan dia. F adalah atas, G adalah bawah dia. Alright, so daripada situ kalau you nampak, okay, sebenarnya F ni saya nak kembangkan ni supaya you jangan confuse. So saya, daripada kita letak X ni, saya akan letak in term of CA. Okay, supaya you jangan confuse lah. So I akan kembangkan as a DCA. Okay, differentiatekan dia. Alright, I keluarkan dia dululah as a FG. Tak nak jadi complicated macam ni, takut you confuse. This one is G. Okay, G ni biasa. Kalau ada ni, maksudnya dia adalah differentiate. This one is DF. Alright, DCA. Okay, jangan takut. Tengok dulu dia punya equation ni. DG, DCA. Alright, over with the G kuasa 2. Okay, saya dah buang X ni supaya awak yang keliru. Okay, daripada sini kalau you tengok, okay, kalau G dengan F kita dah ada dah, which is this one. Okay, tapi you tak ada DF over DCA dengan DG over DCA. Okay, means that you kena pecahkan DF over DCA, differentiatekan antara this one. Okay, you differentiatekan untuk K2CA. Okay, so differentiatekan in term of CA, yang akan tinggal is K2. Okay, so DF over DC is equal to K2. CA dah tak ada lah, you differentiatekan dia hilang lah. Okay, and then we have another one, kita kena differentiatekan pula in term of DG ni, which is DG over with DCA, which is D over DCA. Okay, apa G dia? G dia adalah dekat sini. So G dia adalah K1 plus with the K3 CA kuasa 2. So differentiatekan ni, differentiate K1 ni jadi kosong lah. Sebab dia tak ada CA kan, so yang tinggal this one. So differentiate jadi dG over dCA is equal to 2 K3 CA. Okay, so far faham tak sampai up to this? Konsep dia.
Okay, madam.
Okay. Okay, alright. Okay, sekejap Sekejap ada orang datang pula. Sekejap. Okay, so daripada situ masukkan balik equation dia. Okay, whereby we have a maybe saya boleh tulis kat sebelah kot. Tapi saya tak muat, tak apa. Okay, so we have D over DCA. Okay, so selectivity ni kan, okay, which is K2CA, alright, over with the K1 plus with the K3CA kuasa 2, okay, is equals to, masukkan balik sini. Okay, what is G? Alright, so G adalah this one. So K1 plus with the K3CA kuasa 2 darab dengan DF over DCA. So what is DF over DCA? Adalah this one. So darab dengan K2. Okay, so minus pula. What is F? Okay, yang ni darab tau. Yang dalam kurungan ni darab, ni darab. Okay, okay, so what is F? F is this one. So K2CA darab dengan what is DG over DCA? Is this the one that you differentiatekan dia lah. Darab dengan 2 K3CA. Alright, over with the G kuasa 2. So what is G kuasa 2? Adalah this one. So K1 plus with the K3CA kuasa 2, kuasakan 2 ni. Okay. So daripada sini, remember, kita kena jadikan dia kosong. Which is let D S B XY over with DCA is equal to 0. Okay. So sini, kita akan jadi kosong lah. So bila kosong ada per, kita naikkan sini, dia akan jadi kosong. So what remain is this side only. Okay. So saya ke sebelah sini. So yang tinggal tadi adalah kosong is equal to K1 plus K3 CA kuasa 2, K2 minus feeder, K2 CA. Kalau tak faham, bagi tahu kod 3 CA. Okay, so daripada sini, you bawakan dia ke left side lah. So equatekan dia K1 plus with the K3 CA kuasa 2 times K2. Yang ni you dah bawa ke sini, ni bawa ke sini. So this one, so kalau dia bawakan minus kan sini kan, tapi sebenarnya you dah cancelkan minus dengan ni. So tinggal K2 CA times with the 2K3 CA. Okay, so make sure benda ni kena betul lah, sebab at the end you nak dapat CA tu. Okay, so bila dah equatekan ni, automatically you kena rearrangekan dia. So become K1 plus with the K3 CA kuasa 2. Okay, times with the 2 CA kuasa 2 K3. Okay, so daripada situ we can make it as, okay, K1 is equal to CA kuasa 2 K3. Okay, so disebabkan you dah equatekan dia kuasa 2, sebenarnya dia dah jadi optimum equation, optimum CA. So daripada sini CA is equals to K1 over with K3. Okay, so jawapannya lah K1 over K3. Okay, dalam soalan tu sebenarnya dia dah bagi dah what is value of K1. Okay, so K1 adalah 0.0001 mol over decimeter cube. As K2 K2 adalah 0.0015 S1 and K3 adalah 0.008 decimeter cube mol second. Okay, so masukkan balik nilai K1, okay, which is 0.001 over with K3 which is 0.08. Okay, so your CA value would be equals to 0.112 mol decimeter cube. Okay, that's why bila you buat benda ni kena betul lah, nanti that you punya CA akan lari. Okay, so from here you can calculate what is SBXY. Okay, so the SBXY okay, SBXY is equals to K2CA, okay, per dengan K1 plus with the K3CA kuasa 2. Okay, ini yang the one that yang asal dia tadi, which is this one is equals to RT over RU. Okay, remember yang asal dia adalah this one. Okay, so you just replacekan dia dengan CA*. Okay, so daripada situ just masukkan balik the value CA yang you obtain. Alright, so daripada situ you boleh sama ada kira terus ni ataupun you nak pecahkan balik pun boleh ikutlah. Ataupun tadi kita dapat ni kan K1 over K3. Okay, and then we have a K1 plus with the K3. Okay, CA2 tadi samaan K1 over K3 kuasa 2. Okay, ni misalnya kalau you tak dapat value of CA lah. Okay, tak ada, so jawapannya 0.84. Okay, okay, so faham up till now?
Faham dah.
Okay, faham. Alhamdulillah. Okay, so kalau faham bagus. Okay, sekarang pukul berapa ya? 9:30. You all ada kelas pukul 10 kan?
Ada.
Okay, alright. Okay, so kita go sikit je lagi exercise, maybe sampai exercise 6 je kot. Lepas tu kita sambung minggu depan lah. Alright, okay. So sekarang ni look at this exercise. Okay, selectivity in parallel reactions. Okay, so the question is reactant A decomposed by 3 simultaneous reactions to form 3 products. Okay, that is desired B and 2 that are undesired X and Y. Okay, so sebenarnya soalan ni lebih kurang macam soalan yang sebelum ni lah yang kita buat tadi di rhyme. Okay, alright. So and then given that the value of the K, alright, kalau you nampak the value of K, K1, K2 and K3. Okay, determine the selectivity and volume of reactor if the reaction is carried out to maximize the selectivity of desired product for an entering concentrations of 0.4. Okay, so dia dah bagi entering dia which is CA0 dia lah. So this would be the CA0 which is 0.4 molar. Okay, then a volumetric flow rate which is V ni lah. Okay, is equals to 2.0 decimeter cube over second. Okay, also assess the effect of the temperature on the reactor. Okay, so daripada sini you kena calculate one by one lah. Nak cari dia punya SBXY, dia punya CA and so on. Okay, so daripada situ the first thing you need to do is you need to calculate lah CSTR, volume and X. Okay, sebenarnya selectivity ni dia sama dia question ni. Sekejap. Sama tadi. Sama kan K2CA. Kita sambung ni. Ya betul, dia bersama. Alright. So daripada situ kita dah calculate dah kita dah determine dah selectivity semua tu dengan CA. Okay, sekarang ni kita akan tengok what is volume of CSTR. Okay, so daripada previously, recap balik, SBXY is equals to K2 CA of this one. Okay, then we have a K1 plus with the K3 CA, okay, to the power of 2. Okay, ataupun K2, right, K1 over K3 over with the K1 plus with the K3, ataupun can simplify as K2. Okay, ni kita dah simplify lah, K1, K3 kuasa 2. Okay, so this would be the KD and this one is KD. Okay, ni nanti. Okay, so now is you need to calculate the CSTR volume. Okay, tu lah, setiap topik ni dia memang akan berkaitan dengan previous topik. So that's why you kena have a good understanding about previous ones, but you have to relate all the previous topic dengan yang akan datang ni jugalah. Alright, so remember kalau kita nak tengok CSTR, which is V CSTR is equal to FA0 X over RA. Okay, so RA ni kena remember, this is RA net. Okay, so automatically you kena get dulu what is RA net for these three parallel equation. Okay, which is R1A plus with the R2A plus with the R3A. Okay, so just masukkan benda alah ni. Okay, which is this is in term of positive. Okay, so kalau positif, sini jadi terbalikkan dia jadi negatif lah. Sorry, sini positif, so this one negatif. Okay, so dia akan jadi negatif K1A minus with the K2A CA, okay, minus with the K3A CA kuasa 2. Okay, so kita can make it as negative kat this side. So negative RA net is equals to K1 plus with the K2A CA plus with the K3A CA kuasa 2. Okay, so this would be the RA net. Okay, so daripada sini in CSTR, okay, for liquid reaction, okay, V dia akan remain sama sahaja throughout the reaction. Okay, dia akan sama with the initial at T0. Alright, so from here, you need to get what is the volume. Okay, so what is volume? So V is equals to V0. Okay, CA0 minus with the CA. Okay, over with the negative RA. Okay, ini ada pecahan daripada sini. Okay, remember what is FA0? FA0 is CA0 over with the FA0 is over with the. Okay, so kalau F is equal to C darab dengan V. Okay, so that's why dia jadi macam ni. Okay, tapi sekarang ni kita tak ada dalam C, dia in term of X. Okay, that's why saya dah dapatkan benda alah ni lah. Sebab remember CA is equal to CA0 1 minus X. Okay, so X ni is equal to, you manipulate lah benda ni. Alright, so you boleh cancel. That's why you akan dapat this one. Okay, so you kena play around with the equation. Alright, so from here, we have a V0. Okay, times with the CA0 minus with the CA. Okay, over with the RA, ambil daripada sini. Okay, which is K1. Okay, plus with the K2 CA. Okay, plus with the K3 CA kuasa 2. Okay, so daripada sini kita boleh tahulah what is tau. Okay, sebabnya kita tak ada cukup information. Okay, we can get another one juga. Tau is equal to V over V0. You boleh bawa ke bawah. Okay, so daripada sini, we have a tau is equal to CA0 minus CA. Okay, over with the K1 plus with the K2 CA Okay, plus with the K2 CA kuasa 2. Okay, so masukkan balik nilai dia yang CA dapat tadi 0.12, CA0 adalah daripada ni 0.4. Okay, so you will have a 783 second. Okay, so once you get that, you can get what is volume. So volume is equal to V0 times with the tau. Okay, so V0 itu adalah 2 decimeter cube over second yang provide in the question. Alright, times with the 783 second. Okay, then you will have 1566 decimeter cube. Okay, faham ke so far? Ada yang nak bertanya ke? Okay, so kalau tak ada information yang ada, contohnya kalau FA0 kan VCSCR is equal to FA0 X over RAA, you kena pecahkan FA0 ni. So FA0 ni berkaitan dengan apa? So FA0 ni adalah berkaitan dengan CA0 times V0. Okay, so kalau kita replacekan ni, this is CA0, V0. Sekarang kita ada information X. So X ni kena pecahkan balik. X ni kita kena kaitkan dengan CA dengan CA0. That's why you akan dapat benda ni. Okay, so you kena manipulate the equation in order for you to fit whatever value that you have to get to answer the question lah. Alright, so daripada sini sebenarnya you boleh juga dapatkan X. Okay, sebab apa? Sekarang ni X adalah equals daripada, tengok daripada sini, manipulate daripada sini. Okay, sebab CA is equal to CA0 1 minus X. Okay, so daripada sini manipulatekan dia, X is equals to, rearrange dia, rearrangekan dia CA0 over CA over with the CA0. Okay, so you akan dapat jawapannya dalam 0.72. Ini X. Okay, alright. So daripada situ kita kena dah jawab dah semua soalan. Okay, dah jawab what is selectivity dan what is volume of reactor. Sekarang ni kita nak assess dia in term of the effect of temperature on the selectivity. Okay, so sekarang ni remember kalau berkaitan dengan temperature kita tengok pada activation energy. Alright, so daripada situ kita ada yang the one that we have simplified it is equals to K2 over with the K1, K3 kuasa 2. Okay, so automatically remember ini adalah equals to KD over with the KU, desired over with the undesired. Alright, so automatically kita boleh tahu lah what is AD, what is A2. Alright, so pecahkan dia. Okay, pecahkan dia, dia akan jadi K2 ni replacekan dengan A2. Alright, and 2 ni kita replacekan with A1 and this is A3. Okay, eksponenkan dengan, okay, this one K1 and K3 kan, so E1 plus with the E3 over with 2 minus with the E2 over RT. Okay, so whereby kalau kita tengok standard punya equation adalah, kalau you remember yang awal-awal tadi, SDU is equal to AD over with the AU. Alright, exponential, okay, ED minus with the EU, okay, over with the RT, okay, is equals to KD over KU. Okay, so automatically ini adalah D and ini adalah U. Okay, so this would be the ED. Kalau ni jadi negatif positif, so ini akan EU, ini akan jadi ED. Okay, sebab apa? Ini ada minus. So kalau ini sepatutnya minus ED plus with the EU. Kalau you tengok sekarang minus ni dekat E2. So this one ED lah. Ni positif, ni dekat positif. So this EU. Alright. So you kena tengok kaji case by case, whereby case number 1, okay, if ED what they call it, if E1 plus with the E3 over E2, E over 2 is less than E2. Okay, means that if the EU is less than ED. Okay, so daripada sini kita kena run as high temperature as possible. Alright, with existing equipment ataupun reactor, and watch out for other side reaction. Okay, that might occur. Okay, and then we have another one which is case number 2. If E1 plus with the E3 over 2 lebih daripada E2, means that EU ni sekarang lebih daripada ED. Okay, so dekat sini inversekan balik, dia kena run at low temperature, but not so low lah, but not so low that significant X cannot be achieved. Okay. Okay, so itulah jawapan dia. Okay, semua okay ke so far? Ke dah tepu? Dah saturated dah?
Doktor, itu
Ya.
solo ke follow ke apa?
Mana ya?
Yang run at low temperature but not
So low.
solo.
Okay, so that significant X tu conversion. Significant X cannot be achieved.
Doktor, tadi kan yang masa kita analyse effect of temperature tu kan doktor kan slope dia negatif kan, tapi dalam equation ni slope dia positif, so dia tak effect kan doktor?
Tak. Kita tengok pada ni. Sebenarnya kita dah tengok pada tanda yang ni. So dia tak effect pada situ lah, sebab dia bergantung kepada nilai of the ED dengan EU ni lah. Okay, sebenarnya soalan ni dia ada value untuk E1 dengan E3 ni. So bila kira pun nanti E2 ni memang lagi besar daripada dalam case ni dia bagi sebenarnya E1 adalah 10,000. Okay, E2 adalah 15,000 and E3 adalah 20,000. So bila dia campur 10 campur 20, 30,000 ni bagi 2, 15, dia memang macam dia akan jadi less lah. So nak tengok dia mana satu ED dengan EU, tengok balik pada nilai negatif dengan positif kat sini. Okay, mana you dapat ni lah. Okay, sebab dia ED minus EU. Okay, tengok pada ni. Okay, mana satu KDU. Pasal KD ni adalah berdasarkan dekat ED lah. Yang ni berdasarkan EU. Okay, you tengok kat sini. Okay, so EDU adalah K2. EU adalah ni lah K1 plus K3 over 2 E1 plus 1, sebab kita nak ada average kan. So E1 plus E3 over 2. Okay, so daripada sini kita boleh tahulah directly pun sebenarnya ED tu apa, sebab tengok dari sini pun dah tahu. Okay, kalau ini untuk confirmkan balik lah. Ni sign dia. Okay. Alright ke everyone? So far? Nak saya stop sini ke? And kita continue next week?
Boleh doktor.
Saya rasa better continue next week lah. Saya rasa saya akan drag juga kot lagi satu. Jadinya maybe tutorial minggu lagi satunya. Okey, tak payahlah kita rushing sangat sebab sebenarnya kita tinggal 2 topik saja. 2,5 kot, 2,5 topik. So saya macam bila tengok balik sebenarnya ni boleh buat dalam 2,5 minggu instead of 2 minggu. So kita tak perlu rushing sangat lah. Nak you all betul-betul faham lah sebab ni keluar dalam final assessment kan nanti. One of the big question jugalah. Alright, so kita sambung minggu depan. Minggu depan kita akan habiskan parallel and also series. And lagi satu tu, hari Selasanya lagi satu tu kita buat tutorial lah. Okay, alright, so I think that's all lah for today. We'll continue, we'll resume next week. Alright everyone?
Okey doktor.
Ya, doktor.
Ya, ada apa-apa nak tanya ke?
Tak ada.
Tak ada. Okay, alright. So before we end our class, kita recite